Good morning, students. Today we are going to read electrolysis in industry. In the topic of electrolysis, in the subject of chemistry, O levels. This is one of the very important topic in chemistry, electrolysis in industry. So concentrate yourself. Electrolysis is used in the industry for number one, extraction of the reactive metals. Number two, manufacture of the chemicals. Number three, electroplating of the metals. So now we will read one by one these three things in detail. First is extraction of the reactive metals. Reactive metals are the metals that are high up in the electrochemical series. Metals higher than zinc in the electrochemical series are extracted from their ores by electrolysis. The molten metals ores are electrolyzed to reduce the ores to metals. So the metals above the zinc in the electrochemical series, that are potassium, sodium, calcium, magnesium, aluminium, can be obtained by the electrolysis in industry. Now this topic can be explained, will be explained more in detail with the help of an example. Extraction of the aluminium. Aluminium is extracted from bauxite, Al2O3. Electrolytic process. Electrolyte is purified bauxite dissolved in molten cryolite. Electrodes used in the process are carbon anode and carbon cathode. Ions in the electrolyte are Al3 plus and O2 minus. Electrode reactions are at the anode, O2 minus ions are discharged and the reaction is 2O2 minus forms O2 and 4 electrons are discharged. Oxygen gas is liberated. At the cathode, Al3 plus ions are discharged and the reaction is Al3 plus 3 electrons forms Al. Molten aluminium metal is formed. The second use of electrolysis in the industry is manufacture of the chemicals. So we are going to read in detail this topic now. Chemicals such as chlorine and sodium hydroxide can be obtained from saturated brine by electrolysis. And this is explained with the help of example now. Electrolysis of the concentrated aqueous sodium chloride. Electrolyte is concentrated aqueous sodium chloride, that is NaCl and H2O. Electrodes used in the process are carbon titanium anode and mercury steel cathode. Ions in the electrolyte are Na plus, C minus, H plus and OH negative. Electrode reactions at the anode, chlorine ions are discharged and the reaction is 2Cl minus forms Cl2 plus 2 electrons will be discharged. Chlorine gas is produced at the anode. At the cathode, sodium ions are discharged and the reaction is Na plus 1 electron forms Na. Sodium metal dissolves in mercury to form sodium amalgam. That is, sodium plus mercury forms sodium amalgam. Sodium amalgam reacts with cold water according to the following reaction. And here is the reaction. Sodium amalgam with cold water forms NaOH plus H2 plus Hg. Hydrogen and sodium hydroxide are produced. The third use of the electrolysis in the industry is electroplating of the metals. Now we will read this topic in detail. Electroplating of the metals is carried out to. These are the two purposes of electroplating of the metals. Number one, improve the appearance of the metal. And number two, prevent corrosion of the metal. Figure below shows the setup of an electrolytic cell for carrying out electroplating. This is the setup for carrying out electroplating. Pure metal, that is metal used for electroplating, will be used as the anode, and object to be electroplated will be used as a cathode. Here will be electrolyte aqueous salt of the metal M. Here will be a battery. This is anode, this is cathode. The object to be electroplated must be made the cathode. The anode must be metal used for plating. The electrolyte solution must contain ions of the metals for plating. Electroplating a metal object will improve its appearance and helps to prevent corrosion. Now, electroplating will be discussed more in detail with the help of an example. To copper plate a teaspoon, electrolyte will be copper sulfate solution. Copper sulfate will form copper ion and sulfate ion, and water will form hydrogen ion and hydronium ion and hydroxyl ion. Electrodes in this process will be used. Anode will be pure copper and cathode will be the teaspoon, which is going to be electroplating. Ions in the ions in the electrolyte will be, anions will be OH negative and SO4 2 minus, and cations will be Cu2 plus and H plus. Now, electrode reactions at the anode. OH negative and SO4 2 negative ions migrate to anode, but these ions are not discharged. Copper atoms lose electrons more readily compared to OH negative and SO4 2 negative ions. Each copper atom loses 2 electrons and is oxidized to Cu2 plus. Reaction will be Cu forms Cu2 plus 2 electrons will be discharged. The copper anode dissolves. Now the cathode reaction. H plus and Cu2 plus ions migrate to cathode, but Cu2 plus ions are preferentially discharged. Each Cu2 plus ions gains 2 electrons and is reduced to copper. That is the reaction. Cu2 plus 2 electrons forms copper. A thin layer of the copper metal is deposited on the surface of the teaspoon. So this will be the process. Now we are going to read another example to read in more detail of the process of the electroplating. And the example is, an electric current was passed through the concentrated aqueous sodium chloride. Name the ions present in the electrolyte. So the ions will be present will be Na plus, Cl minus, and H plus and OH negative. B part is, name the product formed at each electrode if the following pairs of the electrodes are used. In first part, carbon anode and cathode will be used, and in second part, iron anode and cathode will be used. So look now. Anode. Chloride ions are discharged. Reaction is 2Cl minus forms Cl2 plus 2 electrons will be discharged. Chlorine gas is produced. This is the reaction at the anode. At cathode, H plus ions are preferentially discharged. Reaction is 2H plus 2 electrons forms hydrogen gas. Hydrogen gas is produced. In second part, When electrodes are iron anode and cathode, the reaction will be at anode. The reaction will be chlorine ions are discharged. And the equation is 2Cl minus forms Cl2 plus 2 electrons. Chlorine gas is produced. And at cathode, Na plus ions are discharged. And reaction is Na plus 1 electron forms Na. Sodium metal will be produced. And C part is less chlorine is produced when using the iron anode compared to the carbon anode. Explain the observation. So here is the observation. Carbon is unreactive. Hence, carbon does not react with the chlorine produced from electrolysis. Chlorine reacts with iron according to the following equation. 2Fe plus 3Cl2 forms 2FeCl3. So this is the reason in one reaction more oxygen is produced and in the second less oxygen is produced. So this was the topic, students. Read this lecture again and make your notes. Thank you so much.